An optimized genetic algorithm for intrusion detection system in data mining. Abstract: the Intrusion Detection System, IDS, plays a significant part in security schemes. Network IDS, NIDS, seems to have a position in the detection of harmful and unauthorized networks and systems among its various forms. The identification of denial of service, DOS, and probe-based threats in most NIDS investigations was reasonably reliable in the literary works. Consequently, in the current big data-based hierarchic deep learning system, BDHDLS, for multiple datasets, the detection rate of many other threat segments remains weak. Machine learning has the capabilities to solve such an inaccuracy problem. In this research, an optimized genetic algorithm, OGA, architecture was proposed for generating strongly optimized results for security analysts both in minor and major attack categories. The evolutionary design is developed utilizing the standard genetic algorithm with optimization of shift-based reverse logic crossover. In the training process where the best particle in the GA interacts with the poor particle in the internal GA to produce new solutions which improve the detection of mutant threats. This means that the optimization method develops the right guidelines for important groups of attacks. Various tests were carried out over multiple datasets with varying settings. The results indicate that the proposed method is more accurate than many established methods and more effective. Keywords: Intrusion Detection System, Deep Learning, Genetic Algorithm, Optimization. Introduction. Despite the technical advances, the majority of real-life activities in the cyber environment are made available. In this modern world, there would also be heavy usage of a wide range of activities such as trading, purchasing, internet research, mobile business and correspondence. Through using mobile in general, people can communicate with this international platform and carry out purchases from wherever also whenever. While digitization enables people to operate every day, leading to network vulnerability and rapidly developing intrusions, communications are mostly invaded by intruders that use the anonymity of the internet not just to steal any data or assets, and sometimes to halt communication services. 1. In parallel to network defense antivirus, security managers typically favor secure passwords, authentication, and security protocols. Such strategies are nevertheless not enough to secure the device. As this illustrates in Figure 1, several managers tend to use IDSs to track network traffic to block anomalous attacks. Any unauthorized behavior which always creates harm to the security, functionality, or credibility of the information in a database model is defined as an intrusion. One such form of operation is strongly prevented by IDSs. Signature-based IDS, SIDS, IDS, and hybrid systems are the three categories of IDS. SIDS maintains suspicious signatures in an information base and attempts to identify intruders using design matching methods. In the meantime, those of IDS make an effort to learn the usual behavior, which is suspicious with some. In such a method, a SIDS is not needed, and the framework may detect zero-day threats not recently experienced. In an attempt to optimize the identification rate of suspected harmful activity by decreasing the false positive rate of zero-day assaults, hybrid systems are composed of the use of SIDS and IDS. Because of the benefits of IDSs, most new IDSs utilize even support from IDS individually. Such IDSs must be learned by analyzing the dataset using the machine learning model. Many studies on this subject have been utilizing old databases comprising obsolete and unbalanced data form volumes too. Although several latest databases containing up-to-date information may be found, researchers also find the unbalanced dimensions of data sort a problem. IDS performance is closely correlated to the chosen training model and data set quality. 3. A high-quality data set are being described as a data set to enhance the efficiency of transactions in the real world. A dataset collection is reported to be imbalanced if the groups are not evenly distributed. This is a general concern related to the datasets used by many of the classification issues. Imbalanced dataset sets contribute to the classification prejudices used by the main class, but in others, the goal is to identify the minority class. This causes a significant category mistake for the samples of the minority community which may be missed for. It can be balanced as per data forms to enhance the accuracy of the data collection. Consequently, the optimized genetic algorithm is used in this study to classify the dataset either malicious intent or not. 2 related works. The researchers in 5 carried out a comparative analysis to address accuracy issues and related factors utilizing algorithms such as extreme learning, support vector machine, SVM, and random forest, RF. The NSLKDD dataset has been utilized and is a reference point for the estimation of IDSs. The findings reveal all of this despite accuracy, specificity, and consistency. Accordingly, the extreme learning method is greater than most other methodologies. The researchers in 6 utilized the dataset sites 001 to manage imbalanced dataset sets for the creation of an effective IDS utilizing a multitude of technologies. Those who systematically study the sites 001 sampling methods and test the data through voting and stacking models using deep neural networks and auto-variation encoder. When utilizing an imbalanced dataset, this device observed attacks with 99.99% precision. The researchers in 7 regulated a machine learning method to distinguish network transmission. For research and preparation, they utilized the NSL-KDD dataset, since they needed to figure out if traffic was suspicious or ordinary. They utilized architectures and function selection methods from Artificial Neural Network, AN, and Support Vector Machine, SVM. The AN with the range of features was more effective than the SVM. The researchers in 8 developed a hybrid model for a dataset KDD CUP99. To decrease the function aspect of the dataset collection, they employed filter-based attribute selection. For the identification of attacks in a dataset, k-means and minimal sequential optimization algorithms have been used. Their approach proposed increases the precision rate considerably. The researchers in 9 utilize the dataset NSL-KDD with an evolutionary ensemble training algorithm to validate and build an IDS. The multiple techniques they utilized: deep neural networks, decision tree, k-nearest neighbor, and random forest. They have also developed a group algorithm for adaptive voting. To validate their method, they were using an NSL-KDD database. The algorithm for decision tree is 84.2% accurate and the adaptive algorithm's final accuracy is 85.2%. They finally compare the corresponding research papers and noticed that their adaptive ensemble paradigm increases the precision of detection. 3 methodologies. A. Existing model. The Big Data Integrated Hierarchical Deep Learning System, BDHDLS, based on was used to arrange multifaceted, hierarchical tree structures for deep learning models was an existing system 10. The hierarchical tree framework is built to separate samples in multiple level clusters, and the single distribution of data is adjusted to every deep learning model learned on similar samples in one single cluster. BDHDLS is designed in 5 stages. The first stage is to isolate and pick behavioral attributes and material functionality utilizing big data technology. In the second stage, a parallel enhanced k-mean method divides the whole dataset into one-level clusters. Samples reveal identical trends from every cluster of the tree. The hierarchical clustering method takes place in the third stage with a poor consistency for each cluster at the same time as producing the cluster subtree. Such subtrees are then merged to create hierarchical multi-level cluster trees. Through particular terms, the whole dataset is broken into various clusters on several layers. Over every cluster in the hierarchy tree, the fourth stage builds a deep learning model to learn the distinctive patterns of data propagation for the cluster. Throughout the final stage, the judgment factors of deep learning methods are integrated to determine whether or not the research sample is invasive. A simple fusion approach was used as the main disadvantage in this existing model to integrate the performance of the various deep learning methods in the cluster that cannot be used to provide heterogeneous data. Furthermore, the specialized fusion-based decision methods that integrate the outcome from numerous deep learning methods are required to maximize performance. This methodology cannot be the ideal solution. B. Proposed model. A. Genetic algorithm, GA. Goldberg's GA was built based on Darwin's theory of evolution, which claims that organism survival has an impact on the most surviving organisms. Darwin even said the reproduction, crossover, and mutation mechanism would ensure the viability of an organism. Darwin's development principle is then generalized to the computer technique to obtain a natural approach to an issue named objective function. The general principle of the GA are as follows. A GA solution is considered as a chromosome, whereas a population is called a chromosome array. A chromosome consists of genes, and its meaning will depend on the issue, either be numeric, conditional, sign or text. Such chromosomes take on a fitness function mechanism to determine the appropriateness of the solution with the problem created by GA. Few chromosomes in the population join through a crossover mechanism that develops various chromosomes known as descendants, the genes becoming their parents' mix. Several chromosomes mutate in their genes over a generation as well. A crossover rate and mutation value are used to monitor the number of chromosomes undergoing crossover and mutation. Chromosomes would be chosen from the population maintained for the next generation based on the Darwinian development theorem. The chromosome with a higher fitness value is most likely to be recalled in the next generation. The chromosome significance corresponds over a range of generations to a definite, the strongest solution for the issue. The following segment includes the pseudocode for GA for IDS. Pseudocode for GA for IDS. Processing phases of GA for IDS. Phase 1, Initializing phase. During the first phase, a zero matrix is developed, or simply a matrix that in all places contains 0 implies initially that it can suggest that it is randomly under the initialization point. Currently, if it is using some element from the dataset, it would take a single function column out of fixed functions, and it only fills in the row or column as row by column of zero matrix, such that the randomly initialized phase is done. Thus, the dataset column can be randomly chosen means from defined functions from the initial input data collection. Phase 2, for every chromosome, the calculation of fitness is done. The fitness function for every chromosome or gene must be determined by the following equation in this stage. Fitness equals 1/1 plus f underscore obj, where f underscore obj equals f, x, equals, a plus 2b plus 3c plus 4d, fixed features. Phase 3, selecting the best. That's the initial fitness measure iteration. In this, 2 of the chromosome top fitness values are picked. Most genes with a fitness value above 93.7% and 96% chromosome fitness value are chosen for the other measures. Currently, this was necessary to repeat this process in iterations 2 and 3, by adjusting the matrix value and calculating fitness values for each freshly formed chromosome, and selecting the maximum value of row or genes or chromosomes for further measures. Phase 4, Solutions. If the fitness attribute is to be more precise, therefore 2 kinds of operators are mainly present, crossover and mutation. Crossover operation. Crossover is the first stage in the reproduction process. It is used to make a whole new chromosome with parents' genes. The traditional recombination for the GA is an action that requires 2 parents, but which may include arrangements for more parents. 2 of the most popular algorithms used are scattered conventional crossover and intermediate blending crossover. In this region, 2 top fitness value genes are taken and the crossover procedure on them is applied. New chromosomes are then developed and the fitness of these newly generated genes must now be calculated. Since crossover, 2 genes or chromosomes have been newly generated, now the fitness of these newly produced genes must be calculated and compared to 2 fitness chromosomes which are the maximum in history. It must now select the 2 genes with the greatest fitness. In this scenario, it would pick the 2 most valuable genes for additional estimation. Mutation procedure on it must be used for further fitness estimation. Mutation operation. In plain terms, the mutation is just by changing the fitness value of every location. The freshly formed population may be further added to mutations by selection and crossover. Mutation indicates certain rows or gene components are altered. These variations can be triggered by errors when the parent genes are copied. For GA, mutation implies a spontaneous shift in the population's significance of the gene. The chromosome, the gene, and the gene alterations are all selected at random. Now that the mutation procedure has been performed, it would choose from 4 genes, just 2 genes to choose from, both chromosomes with the highest fitness. For various matrix configurations of a given dataset collection, the same operations must be performed and the fitness value measured for greater precision. B. Optimization in GA. The shift-reverse logic crossover operation to be used in this research for optimizing GA is following. The colony's primary running parameters are encoded using a binary scheme, which contains the size of the colony M, the probability of crossover Pc, probability of variation Pm and maximum generation quantity T. Make a primary colony of M individuals at random. Evaluate the fitness of the colony's individuals. Determine if the algorithm's final criteria are fulfilled, and if so, avoid it or proceed to the next step. Pick a method for conducting a roulette collection operation depending on the fitness standard. Probability Pc is used to implement the gene reconfiguration crossover process and probability Pm is used to implement the variation operation. Retain the fitness of the individuals that will make up the colony's next generation. For results and discussion. The KDD 1999 Cuban pesos datasets were used to assess methods efficiency over a wide range of research samples. The procedure for the methods of the given dataset is given as follows. The complete dataset was split into 10 batches, with every batch of test sets having its experiment. The data is tabulated and the experimental findings are provided for misuse identification, anomaly detection using existing, BDHDLS, and proposed models, OGA. The true positive rate is the percentage of attack packets correctly found by the IDS out of the total packets. The proportion of regular packets mistakenly marked as attack packets by the IDS to the total packets is known as the false positive rate. The training process of the experiment begins with the selection of a subset of tuples from its data collection. Through the testing process, this subset is never observed again. This subset's tuples are all labeled by corresponding attack category or a normality indicator. The testing process continues after the training phase is finished. The tuples are not labeled during the testing process. The misuse identification method processes the tuples first. The outcome has been processed if the program could categorize the packet data with adequate trust. The tuple was being moved to anomaly detection process if the categorization is not confident. Both suspicious tuples were compiled and combined with an established dataset with a strong occurrence of regular packets while anomaly detection. This is accomplished after every session. The OGA and BDHDLS methods were assigned to the merged data. When a suspicious tuple is classified as an anomaly, the method suspects it is related to a new threat. Or else, the tuple is identical to a regular packet. Table 1 and Figure 2 show the performance rate of the TP in which the rate gets affected depending on the variation in the number of samples ranging from 2000 to 10,000. The higher TP rate will prove better accuracy. Thus for the given dataset, the performance of the TP rate is better for the proposed OGA when compared with the existing BDHDLS. Hence it proves for a larger dataset the OGA will give better accuracy for identifying the intruder dataset. Table 2 and Figure 3 show the performance rate of the FP in which the rate gets affected depending on the variation in the number of samples ranging from 2000 to 10,000. The lower FP rate will prove better accuracy. Thus for the given dataset, the performance of the FP rate is better for the proposed OGA when compared with the existing BDHDLS. Hence it proves for a larger dataset the OGA will give better accuracy for identifying the normal dataset. Conclusion. Because of the widespread usage of the Internet in recent decades, computer machines may now link to an international platform at whatever time and in any place. Even so, the anonymous nature of the Internet leads to several security flaws in the network, resulting in intrusions. Furthermore, today's hackers are much more advanced and could innovate real malware with the aid of automated development software, relying on IDS limited detection capabilities. In certain instances, pre-collected datasets are used to train IDS. Most of these databases, though, are unbalanced, with varying mismatch ratios. Imbalanced datasets lead to bias in favor of the dominant party, although in certain rare cases, minority groups are completely overlooked. Such minority groups, on the other hand, are mostly optimistic. As a consequence, the imbalance ratio can be lowered to boost the system's performance while not lowering its average accuracy. In this article, OGA is introduced as an IDS that can effectively identify different forms of network intrusions and harmful behaviors as compared to the existing BDHDLS framework. In the future the research moved towards many real-time data with a good accuracy rate.